Hello there. In this lesson today we're going to talk about the cannonball problem. And in this cannonball problem you imagine yourself fighting the British. You're not fighting aside William Wallace, if that's what you think. It's actually you're fighting for the independence of the United States from England. So in this particular case, the English are very neat when they stack their balls. They have one ball followed by four, and then each one of these four balls is set on another set of four, so that would make it 9, and so on and so forth. Now you as a spy, you can only see how high the stack is, and based on how the English stack the balls, you're supposed to figure out how many balls there are. So this is kind of a little bit more clearer than the previous picture. If you just have one ball, then your height is 1. So if you just have one ball, if you have height of 1, then this means you have just one ball. If you have a height of 2, then you see two balls. That is 1 and 2. The height is 2. So you have 4 balls and 1 above it, so the total number is going to be 5. If you have height 3, then you're going to have 9 balls down at 3, and then 4 balls, and then 1 ball. So this is going to give you 15 balls, 14 balls, sorry, and so on and so forth. To visualize this problem and to explain the approach, first let's divide the problem into two separate problems. The first problem is trying to figure out what is the size of the layer with respect to its height, and in the second problem is how we can calculate the number of balls. So if we have height of 1, then we only have one ball. So if you see layer 1 has one ball in it. Layer 2 is interesting. It has 4 balls, 1, 2, 3, 4, and it's basically 2 multiplied by 2. Notice the relationship. Layer 2, height 2 times 2. Layer 3 has 9 balls in it. 1, 2, 3, 4, 5, 6, 7, 8, 9, which is 3 times 3. Layer 4 has 16. 1, 2, 3, 4 times 1, 2, 3, 4 gives us 16. So now we know kind of the layer, how it relates, the number of balls that would happen in every layer. In order to see this in practice, let's look at the following illustration. This is here you have layer 1 and it just has one ball in it. So the height is 1. Now imagine you're looking at this pyramid of balls from the top of it. If you have a height of 2, then you're going to have 2 layers. Layer 1, which has 1 ball, and layer 2, which is going to have 4 balls. And layer 3, we add layer 1 and layer 2 to layer 3. Layer 3 has 9 balls, layer 2 has 4 balls, and layer 1 has 1 ball. This will give us 14 balls. And then in layer 4 we do the same, and so on and so forth. And here we can see a recurrence relation being developed. The number of balls in a particular layer, I assume that it's layer number 4, is equal to the number of balls in the previous layer plus the number of balls in this layer. So in layer 3, if we want to know how many balls there are, we know that there is 9 plus how many balls in the previous layers. That's layer 2 and layer 1. The number of balls in the layer is easy. It's basically the layer number squared. So 2 times 2 is 4, or 3 times 3 is 9, or 4 times 4 is 16. The number of balls in the previous layer equals the previous layer number minus 1 squared. And this is, you have the recurrence relation. So imagine we are at layer 2, then it's going to be 2 times 2 plus the number of balls in the previous layer. Previous layer is layer 1, it just has 1 ball in it. So it's going to be 2 times 2 is 4 plus 1. is going to give us 5, and our base case is that the height is equal to 1. The code is very simple, and again, this is written in JavaScript. Our base case is the height is equal to 1, we return 1, and here you see we calculate the number of balls in any particular layer as the number of balls in that particular layer squared plus the number of balls in the previous layer. Very beautifully recursive function, and it actually works. So let's take a look at the backtrace of this code in order to get a better understanding for it. Assume you want to see how many balls there are in a canon of height 4, and just to remind you with the formula, it's n squared plus the number of balls in the previous layer. So in our first call, we're going to get 4 times 4 plus the canon of 3. Canon 3 is height minus 1, which is the previous layer is layer 3. So 4 minus 1 is going to give us 3. This in turn will call another recursive call, which is going to give us 3 times 3 plus canon 2. Notice the decrement from 3 to 2. And then canon 2 is 2 times 2 plus canon 1. Again, we decrement the number of balls in this layer plus the number of balls on all the previous layers. Now we have the height of 1, and this return 1. And then this 1 will replace the canon 1 here. So we're going to get 2 times 2 plus 1 is going to give us 5. 5 will replace canon 2. 3 times 3 plus 5 is going to give us 14. And 14 is going to replace canon 3. So we're going to have 4 times 4 plus 14, which is going to give us 30.